When modelling populations, we are interested in several things. What behaviours does the model have, and how do these behaviours depend on the model parameters? One of these behaviours is the location of fixed points in the system. Given a nonlinear single population model in discrete time of the form population size at time t plus 1 is equal to the population at time t times by some nonlinear growth function dependent on the population at time t. This can all be written as equal to h of nt. It is possible to identify fixed points in the population, that is to say, find a value for the population such that the next iteration does not change from the original point. Or, n star, the fixed point, satisfies n star equals n star times the growth function, g of n star, or is equal to h of n star. One obvious, or trivial, value that satisfies this is when n star equals 0, i.e. 0 times g of 0 will always be equal to 0, even if g of 0 does not give 0. This is called the trivial fixed point. Now because of this, if we assume that there exists a non-trivial fixed point, n star is greater than 0, worth noting that population cannot be negative, thus populations greater and equal to 0 are the only biologically relevant populations. Using the definition of n star is equal to n star times g of n star, and we know that n star is non-zero, this allows us to divide both sides of the equation by n star, resulting in 1 equals g of n star, which in most cases can be solved algebraically for n star, finding the other fixed point of your model. In this example, we'll be looking at the Beaverton-Holt model, which is given by nt plus 1 is equal to rnt divided by 1 plus nt over k, where r and k are positive numbers. For the sake of simplicity, we shall fix k to be equal to 1. This gives us nt plus 1 is equal to rnt all over 1 plus nt. This fits our general form of nt plus 1 equals nt times g of nt, with g of nt being given by r over 1 plus nt. We can see that the trivial solution of n star equals 0 does exist in this case, and now we look for non-trivial fixed points n star greater than 0 such that n star equals rn star over 1 plus n star. We can first divide each side by n star, giving 1 equals gn star or equals r over 1 plus n star. This can then be rearranged as 1 plus n star is equal to r, and thus n star is equal to r minus 1. So our other fixed point of the system is n star equals r minus 1. Now we have found the fixed point, there are ways to classify it which we will be looking at in the next video.